I need some juice. It's like a baseball player with a walkout song, you know? That's what I'm doing here. Start a second semester. Still in remote learning. Coronavirus is still wreaking havoc on our math learning. We'll adapt or persevere. Can I spell persevere? Probably not. I'm a math teacher. Alright, let's get into it. For those of you who probably don't know me, that's probably a little weird. I am a little bit goofy. Okay, if you're new to the class, we welcome you. Okay, hopefully we can welcome you in person. Hopefully we can form a relationship, whether it's through Zoom calls, Schoology messages. I don't know. I'm here for you guys. Okay. I'm gonna try to do the best I can. I actually found a cool way to record. I can use it using my streaming setup. I left my Twitch viewers up there. That's so sad. See, we're great here. Oh, 0 viewers. Tough. Tough life. Okay, it's actually really better. Rather than using Zoom, I don't like the quality of Zoom sometimes. I don't know, my OCD kicking in. Okay, so 4.6. 4.6 is a little bit tough. Why is it tough? Number one, you guys are coming back from break, and we all know how that goes, right? Our brains have been turned off for about 3 weeks now, so a lot of this will probably go over your head. Okay, just as far as initial me trying to teach it to you, you trying to learn it, you staring at your screen, you staring at me like, I have no idea what I'm doing. Okay, so let's talk about if that happens, because that's going to happen. So if you have no idea what you're doing and no idea what I'm talking about, I am available for Zoom office hours pretty much all day, every day. Let's amend that statement. All day, no, hold on. Every day from, what are the school hours? 7 to 2:45. I'm not going to Zoom you at 7. 8 to 2:45. Okay? So 8 to 2:45, I'm there for you. So in between your other mandatory Zoom calls or in between your other classrooms or doing homework, if you want to pop into a Zoom, you just got to shoot me a message an hour ahead of time, okay? All right, I have Schoology pulled up for a reason. Okay, I'm going to be a lot more organized. I have 22 messages. I have read those. I just don't know why I can't get the notification to go away. I don't know. It's like a bug in Schoology or something. Okay, so here's the deal. So here is your outline for Chapter 4, Part 2, right? We're starting 4.6 on 1/5/21. Okay, and yes, I know the dates are wrong. Do not roast me about that. I don't even want to hear it. I know if we were in person, you guys will be like, well, the dates are wrong. Well, sorry, I got the first one right. Partial credit, man. Name of the game. Okay, so we're on 4.6, fundamental theorem of algebra. Okay, it sounds fancy. It's not. Okay, the process is hard. We'll get into that. Okay, fundamental theorem of algebra is really just counting how many zeros do you have. And what are zeros? Waiting for a response. Remember, zeros are where it crosses the x-axis, where your y value is 0. So the x values that make your y value 0. That's what they're called, zeros, or solutions, or yada yada. Okay? Alright, Thursday. Is it going to be Thursday? What's today? Monday? No, it's Wednesday. No. Tuesday, Thursday. Yeah, this is Thursday. Okay, we'll be 4.7. Notice how it's all nice and neat for you, and it's the first thing that pops up. Okay, that's what I'm trying to get better at. I'm trying to get better at making this easy for you guys. Okay, for those of you that actually do it. Okay, a couple things that changed from last semester. I am going to be taking not daily, okay? So I'm going to be taking attendance. So for the first day, I'm going to post a YouTube video tomorrow. Is attendance really a big issue tomorrow? No, I'm not worried about it. It's first day. Okay? But the thing is, I'm posting all this through Delta Math. I'm going to be posting all these videos through Delta Math. Okay, so if you are not signed up through Delta Math, that is a big problem. Okay, you need to get signed up. How do you get signed up? Well, good thing you can actually do this. You can even click on the Schoology extra credit assignment I gave you. Delta Math login instructions. Boom, pull it up. Okay, you go to your Delta Math website. It has everything for you. Okay, it even has my teacher access code that you're going to plug in and make your student account with. Make sure you are in the right period. If you're in period 1, put yourself in period 1, obviously. Okay, make sure your names are your actual names. I don't need Dragon Slayer 22. I don't need that. Okay, maybe in the gaming community, but not in the math community. I don't need Dragon Slayer 22. How am I supposed to know who Dragon Slayer 22 is? I'm the best Dragon Slayer, and everybody knows it. So get with it. I'm Dragon Slayer number 1. So how do I know who 22 is? I ain't even worried about that far down. Alright, sorry. Yeah, so this is how you get to it. So all you gotta do is click Mrs. Huling made this for us. That is amazing. Thank her. Okay. All you gotta do is follow these directions and get signed up for Delta Math. That's first priority. Second priority, familiarize yourself with the homework. Okay, the homework, how the folders are labeled out. Go to materials. If you need help with anything, class information, here's Delta Math, the link, you can click on that. Here's that Word document I just showed you. Here's Desmos, we will get into that, okay? We'll get into the Desmos. My YouTube page link, where all these videos are going to be posted. If you want to go straight to my YouTube link, subscribe to that so you get notifications so you don't have to go through Delta Math, sure. But remember, I'm still taking attendance on Delta Math, so even if you do watch it on the YouTube link, at least show me you clicked on it, because I can see all that. I can see how much time you watched it. I can click on how fast you did it. What else can I see? That's pretty much it, just for videos. Yeah. What you actually watched. So if you watched it for like 5 seconds, I can still see that. Okay, I get it if you watched it on YouTube and you just want to open it for 5 seconds. All I'm asking you guys to do is click on the link in Delta Math. That will be your daily attendance every day. If you do not click on that link before 11:50, like tomorrow, for example, if I was taking exact attendance, if you don't click on that link before 11:50, I'm going to mark you absent. Okay, Tuesday is our homework day, so you're going to work on the homework from this section that we're learning today. Okay, it's Tuesday. You can go in and view the video. I will mark you as present. Okay. Also, my syllabus lays out everything for you. Okay, I will post a hard copy on Schoology after the assignment's due on Friday, but it lays out this whole class. So go and read that. I know you guys hate reading syllabuses or syllabi if you want to sound smart, but you got to do it. Actually, I already posted it. It's right here. Okay, but still do that Delta Math assignment. It's like a Delta Math scavenger hunt. Okay, that tells me you know how to access my assignments and my videos. Cool. Okay, should we get into it? Little synthetic division going on here, a little graphing going on. Alright, let's get into it. Okay, first things first, just a quick review. Here's what fundamental theorem of algebra is in, I don't think I can do 5 words or less. Okay, here's what it is. So, you look at, why not? Let's look at all 4 of these polynomials. Okay, the fundamental theorem of algebra says, what is my highest power in number 1? What's the highest power there? Okay, is it 3? No, right? Why is it not 3? Is it 2? No, it's not 2. Is it 1? No. Okay, it's going to be 4. My highest power is going to be 4. This is already in standard form. The highest power to least. Okay, that's what standard form is. Reminder. Okay, so it's easy to see. So my highest power is going to be 4. What does that mean? I'm going to have 4 solutions. Okay? That tells me how many zeros or solutions I'm going to have to the polynomial. Okay, number 2, it's easy. These should go really quick. 3 solutions. Okay? Does that mean it's crossing the x-axis 3 times? We'll get into that. Okay, I said 3 solutions. What are the 2 types of solutions we could have? We could have a real solution, which is just a number, right? Any integer. Okay, or we can have imaginary. Remember, imaginary starts with I. Okay, that's a variable. Anytime you see an I, like a plus bi, something like that, that's complex number, right? But this bi is the imaginary part. We will get into that. Okay, that should be a review based on last semester, but I kind of know how last semester went, right? A lot of just getting by last semester. I want us to be better this semester. Okay, number 3. 4 solutions. I'm not saying real or imaginary. I'm just saying 4 solutions. Could be any combination. We'll actually learn about even and odd functions, which will be cool next time. Okay, and number 4, you have 3 solutions. That is the fundamental theorem of algebra. Highest power tells you how many solutions. Does that mean how many times it crosses the x-axis? No, right? It tells me nothing about the real and imaginary just yet for you guys today. We'll learn more about that on Thursday, I think. Okay? So we want to find all the zeros of the polynomial function. Okay? This is hard. Why is this hard? Because you guys are only used to finding the zeros of quadratics. Okay? So how do we do this? Well, it's pretty easy, right? Watch this. We have a ton of tools at our disposal here. What if I just go to Desmos? And for those of you that don't know what Desmos is, you need to learn Desmos. It's like your graphing calculator, but a million times better. Okay? It's like the one good thing to come out of remote learning. You guys learning how to do Desmos. Here's what we want to do. We want to plug this function into Desmos, and this is the first step. Okay? We want to plug this function into Desmos, and we want to see how many real solutions this has. What does a real solution mean? It means it's a whole number. And if I click on those two dots, it stays for me. Okay? So this is going to tell us two solutions right off the bat. What are the two solutions? -2 and 3. +3, right? Okay? That's the first step. So I'll write our steps down. So here we go. If it's going to work. Oh, come on. There we go. I thought it was lagging on me. I was like, oh, no, I'm going to restart the video. Okay, we're good. Okay, first step. Graph and find real solutions. Okay, that's easy, right? So what do we get? We got -3, or -2, excuse me, and 3 from graph. Did I have to do any fancy math there? I didn't, right? I got -2 and 3, +3 from the graph. Okay, here's the second step. We want to, remember what I said, right? We know how to, it looks like a figure 8, sorry, squirrel. Okay, we know how to find the zeros of a quadratic equation. Well, how can we get down to a quadratic equation? We got to use synthetic division to simplify it down to a quadratic equation. Then we can find the other two zeros, or the other two solutions. Whether they're real or imaginary, we'll see, right? Synthetic division to get a quadratic formula. Okay, so this is the part where it's probably going to go over your head, right? Synthetic division, if you guys did not pay attention when I taught that last, it's on my YouTube channel. Okay, you can go back and look at it and review it, or you just pay attention right now. I'll do it a little quicker because I already taught it, right? I can't spend the time teaching it. I'm not trying to make an hour-long video. Okay, you can ask me through Zoom, or you can go back and watch an old YouTube video. I have all that pulled up for you. Okay, so here we go. Synthetic division. I'm going to use these real solutions that I got from the graph. I'm going to use -2 first. So remember, whatever my solution is, I'm going to be putting it in the box. Okay, now what do I put to the right of it? Remember, I put the coefficients to the right of it. So I'm going to put 1, -3, 6, 2, -60. Okay, remember the process for synthetic division. We drop the 1 straight down. And then I multiply. -1 times, or 1 times -2 is going to be -2. I add. Okay, so -3 plus -2 is going to give me -5. -2 times -5 is going to give me +10. 6 plus 10 gives me 16. This is synthetic division. -2 plus 16 is what? -32? Okay, usually you guys would answer that, but I don't know why I paused for effect. Oh, that's a teacher coming out at me. Okay, so 2 plus -32 will be -30. And guess what? -2 times -30 is 60. And we get 0 as our remainder. Remember, if you get 0 as your remainder, this means that -2 is a 0 of the function. But we already knew that, right? That's not the point. Okay, the point is we want to start breaking this quartic polynomial down to a cubic, then down to a quadratic. Okay? So we actually just broke this down to a cubic. but these are my coefficients of my cubic now. Okay, so it's just one less than it was above. It was quartic here, now it's cubic. So keep going in standard form. Greatest power to least power. Here's going to be my squared, my single x, and my constant. Alright? So now let's do synthetic division again. So now we're going to have 3, which that's my other real solution. So now we're going to have 3. What do I plug in to the right of it? I plug in these coefficients, right, from my cubic function now. Because I want to break it down to a quadratic so that we can solve it. Alright? So remember the process. Drop the 1 straight down. 1 times 3 is 3. Okay? Negative 5 plus 3 is negative 2. 3 plus, or times a negative 2 is going to give me negative 6. It's going to give me 10. It's going to give me 30. And you should get 0. If you do not get 0, you did it wrong. Okay? Sounds harsh, but I don't mean it like that. I just mean we know 3 is a 0. Okay? So you should get 0 as a remainder. Okay. So now I have my quadratic. So let me write out my full quadratic for you so you guys can see it better. Here's my coefficients. Remember, it's 1 less. This one is cubic. We went from quartic to cubic to quadratic. Here's my single x, and here's my constant. So we're going to have 1x squared minus 2x plus 10. Okay, we have 2 ways to solve a quadratic, right? We can either plug that into Desmos and see what I get. Probably not a good way. Okay? You're probably not going to find anything. Just a hint. So don't try it. Usually, when we plug in to Desmos at the beginning, right, that tells me all the real solutions. So really, if I plug this into Desmos right here, and I know some of you guys have tried, you're not going to get anything. You're not going to see anything. Okay? There's a reason for that. So what can we use? Can we factor it? No, we can't, right? No factors of 10 can get me to negative 2. 5 and 2? No, I can't get me to negative 2. Okay? So what's the third way? I have the quadratic formula. We could use that. Don't forget, quadratic formula is this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That should be ingrained in your brains by now. Okay, I'll pause for a second if you want to take a picture of that. And we're moving on. Remember, these are it's all on my filled in notes. Okay, I have a whole new folder for filled in notes. Okay, so let's use a quadratic formula. So let's just write our variables first. What's my a variable going to be? My a is going to be 1. Remember, my b is going to be negative 2. My c is going to be 10. Okay. Alright, so we have negative b, so we have 2. Negative 2, which is giving me positive 2, but I won't skip the step. I'll show every step. Plus or minus the square root of b squared, negative 2 squared, minus 4 times 1, which is my a, times positive 10, which is my c, all over 2 times 1. Okay, let's simplify it down because that looks gross. 2 negatives make a positive, so we have positive 2 plus or minus the square root of, this is 4 minus minus 40. Because we have negative 4 times 1, so it's going to be negative 4. Negative 4 times 10 is going to be negative 40. Okay, so we have 2 plus or minus 4 minus 40 is going to give me negative 36, goes inside the parentheses, all over 2. Okay, this is where light bulbs should be going off in your brains. All right, we talked about this. What can we never take the square root of? We can never take the square root of a negative number. Okay, so how do we do this one? Well, we have 2 plus or minus the square root of, can I pull out an I? Remember that? Can I make this I square root 36? And now we can take the square root? We can. Okay? So if I have I square root 36, what's the square root of 36? It's going to be 6. We still have the I attached to it. And don't forget to put it all over 2. Okay, we're almost done. So I can simplify this down. We have 1. 2 over 2 is 1. plus or minus 6 divided by 2 is going to be 3i. Okay, so let's talk about what we just did. Was it a long problem? Yeah, it was. Okay, am I going to do all 4 of these? Probably not, because they're already in your filled-in notes. You can go look how to do it. I might show you a couple. Okay, it really doesn't take a long time. I'm just teaching it, right? It takes a long time to teach, but once you get it down, it's pretty simple. The hardest thing that we had to do here was a quadratic formula. We should be pretty good at that. Okay, but what did we just get? Okay, right off the bat, we got 2 real solutions here. Okay, we got 2 real solutions. Uh-oh. But here comes my 2 imaginary solutions. Okay? Remember, the real solutions is where it physically crosses the x-axis. Okay, your 2 imaginary solutions are the 2 that are hidden, right? So we know the leading or the highest power is going to be 4, so we know we were going to have 4 solutions. We got 2 real solutions, and we got 2 imaginary solutions, and that will be a theme for Quartix. We'll get into that, though. Okay, so we got 2 real, 2 imaginary. Take a breath. You just did your first one. Applause. Okay, we're only 20 minutes into the video. I did have to introduce some stuff, though. Okay, let's jump into number 2. So number 2, first things first. Let's go to our steps. Graph to find the real solutions, that's number 1. Well, we can do that. I just so happen to have this conveniently pulled up. Let's zoom out so we can see the full thing. Okay, we zoomed out all the way. Okay, this is what the full graph looks like, so you can see it. Okay, what is the real solution that we have? We're only going to have 1 real solution, which is going to be -5. Okay. We have -5 from the graph. And now, what do we do with that -5? Well, look at your steps. We found the real solutions, right? Now we use synthetic division to get a quadratic formula to find the imaginary solutions. Or real solutions, okay? But majority of the time it's going to be imaginary. We just found the only real solution, and we know there has to be 3. Why do we know there has to be 3? Because this is a cubic polynomial. Its highest power is 3, so that means we're going to have 3 solutions. We already have 1 real. Now we need to find the 2 imaginary solutions. Okay, how do we do that? We use synthetic division. What goes in the box? Your real solution goes in the box. Okay, what goes to the right of it? Your coefficients. We have 1, -3, -15, and positive 125. Okay, where am I getting those? Am I pulling them out of thin air? No. I'm getting it from my coefficients. I have 1 right here, boom. -3 right here, boom, -15, 125. Okay, now this comes down to, can we do synthetic division? We can. Drop the 1 straight down. Multiply, we have -5 times 1. What is that? -5. Add. Okay, -3 times -5, or plus -5. So to give me -8. Now you multiply. We get positive 40. -8 times -5 is going to be positive 40. Okay? What's -15 plus 40? It's going to be positive 25. Now we multiply, and we get -125 with a remainder of 0. Is that a shocker? No, it's not. Okay, I talked about it last problem. It's a solution. It's a 0. You should get 0 as the remainder. That's what makes it a solution. Okay, so now we got to make it into a quadratic. We're going to only get up to this once, so cubics are actually a lot easier than quartics. Okay, so we have cubic, we turn to a quadratic, so it's going to be x squared minus 8x plus 25. Okay, how are we going to solve this? Are you going to waste time factoring? Don't. Plug it right into the quadratic formula. Okay, let's talk about what our variables are. My a is going to be 1. My b is going to be -8. And my c is going to be 25. Let's plug in our values. So we have -b, -8. I won't skip steps. Plus or minus square root of b squared, which is -8 squared, minus 4 times 1 times 25. All over 2 times a, which is 1. I know, it looks confusing. Don't make it confusing. Don't skip steps. Okay, go one by one. Alright, so let's simplify. This looks ugly. Let's make it look pretty. It's like when I go to the haircut place. Just kidding. That won't help. 2 negatives make 8 positive. We have 8 plus or minus. Negative 8 squared is going to be 64. Okay, minus 4 times 1, which is going to be 4. 4 times 25 is going to be minus 100. Okay, it's going to give me another negative 36. Shocker. Over 2. Alright, we should be getting faster at this. We know this is going to turn into 6i. Because we take the negative out, we take the square root of 36, yada yada, it's going to be 6i. Alright, so we know we're going to have 8 plus or minus 6i over 2. Let's simplify. We have 4 plus or minus 3i. Boom. Here's my 2 imaginary solutions. So I got my 1 real solution, which is negative 5, and my 2 imaginary solutions, which is 4 plus or minus 3i. It's a complex number. We good? My dog's just looking at me. What do you want? I'm working. See ya. Okay, let me know if you guys got questions. That probably went over your head a little bit. Okay, just try to re-watch the video. I used fancy colors. Okay, so you guys can see what's going on. I'm taking a lot of time to do this for you. I think this is a lot better than Zoom calls because I get to take my time. There's no connection issues. There's none of that. It's just you and me, and you're watching the video. Okay. Here's a hint. This one's kind of cool. Okay, I know I said I was only going to do 2. I'll do 3. I'm going to skip 4. 4 is way too hard. Okay, it's got a fraction in it. Do you want to do a fraction? No. I changed it in my filled in notes. If you want to do another one to double check, I changed that problem in my filled in notes. So go take a look at that in the folder. Okay, this one's actually pretty cool. Okay, I'm going to use a math trick here. Watch. Could we go ahead and use the same process? Yeah, we could. But let's use tools. Let's get fancy with it. What if I'm going to tell you can factor this. What if I just set, I don't know, a variable? Any variable. We already have x. Let's use the other variable we know. Let's set y equal to x squared. Okay? And now I'm going to do the problem. And I'm going to plug x squared back in when I have it factored. Watch this. Boom. That's what that becomes. When I make y equals x squared, that equation becomes my new y, my y squared minus 48y minus 49. Now I can factor that. How can I factor it? Remember, make your 2 parentheses. We have y and y. Okay. Now, what factors of 49 can get me to negative 48? What's negative 49 plus 1? Okay, so first, outer is going to give me negative plus 1. Okay, a little bit of factor in view there. Because remember, negative 49 plus 1 is going to give me negative 48. Now, plug in what x originally equals. My x originally equals y. My x squared equals y. So let's plug x squared back into the problem. Now, if you're getting confused, just do it like we did. Okay, the only thing different here is you're going to need a placeholder. For your cubed. In your synthetic division. So that coefficient is going to be 0. That's the only difference. Okay, but if you want to do it the fancy way, this is how I'm doing it. Okay, now I have it factored. Do I have it factored all the way? I don't, right? Okay, I don't whatsoever. How can I factor this further? Well, let's think. Okay, what's the difference of 2 squares? Anybody remember that one? So I can't factor this one. Hint, I cannot factor this. So let's knock this one out. So we set this one equal to 0. Zero product property. We'll talk about that later. About 5 minutes here. Okay? We have x squared plus 1 equals 0. I'm going to get x squared. I'm going to subtract the 1 over. Equals negative 1. I square both sides. I get x equals plus or minus I. Okay, remember, square root of negative 1 is I. Okay. Boom. There's my two imaginary. How many total am I supposed to have? 4, right? Why do I know that? Because the highest power is 4. Okay. Now, remember, this is different to two squares. Listen. This is a factoring tool we can use. Boom. That is difference of two squares. That is always a rule. If this is a perfect square, which x squared is, x times x, and this is a perfect square, and they have a minus sign in between them, that's called difference of two squares. Okay? I take the two factors, I take one positive 7, one negative 7, and that's it. It's a quick way to do it. Zero product property, I set both these equal to 0, I get x equals negative 7 from this one, positive 7 for this one, so I'm going to write it like plus or minus 7. Okay, and I have two real solutions. 2 plus 2 equals 4. See, it all comes down. 2 plus 2 equals 4. Come on now. Alright, so you guys should be printing off the filled in notes and copying them down. If you need a hard copy of the notes, all you gotta do is let me know. I'll find a way to get it to you. Okay, come by the school, I'll run one out to the car, whatever I need to do. Okay, so that's it. That's part 1. Okay, let's go ahead and knock out part 2 now. The complex conjugates theorem. Remember, this is a very fancy wording. Okay, what this is saying is the whole point of the complex conjugate theorem is that when I have, so down below it's going to give me factors. It's going to give me zeros, okay? And it's going to want me to reverse of what we just did. So we're doing the exact opposite. So I'm going to put these all in their binomial forms, and then we're going to multiply them out to get the original polynomial. Okay, it's actually pretty easy. But what this is saying, I want us really to pay attention here, is if I tell you, or if somebody or the worksheet tells you that you have a 0 of negative I, does that make any sense? Okay, think about it. Can I just get a 0 to be negative I? Well, how could we get to negative I? Well, I could have this. What do we do over here? What do we do right here? What if I had this same scenario where I have x squared equals negative 1? The only way I can solve that is I have to square root both sides. But remember, when you square root something, what do you always have to put in front? A plus and a minus in front. So what the complex conjugate theorem is, if we give you a negative or a positive half of a complex number or imaginary number, you need to fill in with your brains the other half of it. So same thing here. If I give you a positive complex number, you need to know that there's also a negative complex number. There's a positive half and a negative half. So for example, let's go ahead and knock these out since we're talking about it now. Okay, do I have to worry about anything to do with that up here? No, I don't, right? Those are pretty straightforward. I just turn these back into their binomials and I multiply out, FOIL out. Okay? But down here, we do have to worry about it. So remember what I said. This is a complex number here. This is a negative half. What do we need to fill in? We need to fill in a positive half. You can't have just one negative I. Okay, the whole point of getting an I is square rooting. When you square root, you have to use the plus or minus. There has to be two halves. Okay? Remember, like 36, square root of 36. Right? It could be negative 6. It could be positive 6. Right? Negative 6 times negative 6 is still positive 36. 6, a positive 6 plus, or times a positive 6 is still positive 36. You got to have both halves. Okay, over here, you have 2 plus 3i. We have the positive half. We need to fill in the negative half. And then go ahead and solve it. Okay, we'll get into it. Let me switch my notes here. I got a cheat sheet so I don't mess up once and have to redo the whole video. It does happen at 8:30 at night, for sure. Okay, I will screw up multiple times. Okay, so number 5. I told you guys these are pretty simple. They are. I'm not lying to you. Okay, here's what we want to do. The first step, I'm a steps guy. I teach in steps. We want to turn these zeros back into their binomial forms. Remember, binomials are the parentheses with 2 terms. So this will turn into, I'll write it down here, x plus 4, I will talk about it, x minus 1. Why is it opposite, Mr. Sandifer? Oh, I'm going to tell you right now. Okay? Why is it opposite? Think about it. Okay, how do we get zeros in the first place? We use a zero product property. Okay, we want to use the binomials, so when I set each of these to 0 and solve for x, I'm going to get these 3 numbers. Okay, those are the binomials that we want to use. So yes, it's going to be opposite, but you should know why. Don't just say, okay, it's opposite, so I'm just going to write opposite. You need to know why it's opposite. Okay? Alright, so now, what do we want to do? We want to turn it back into a polynomial form. Well, we can multiply 3 binomials together. It's not hard. It's a lot of busy work, but it's not hard. It's 4 sets of foiling, really. So here's what we want to do. First, outer, inner, last on the first 2 binomials. So my first is going to give me x squared. My outer is going to give me negative x. My inner is going to give me positive 4x. My last is going to give me negative 4. Okay, we still need to simplify here. X squared, negative x plus 4x is going to give me positive 3x, minus 4, and don't forget about that last binomial. Okay, now we have a trinomial. We have 3. Let me line it up right. We have 3, times it, there we go. We have a 3, a trinomial, times a binomial, which is 2. Okay, that camera's opposite. It's throwing me off. How do we do that? Okay, here's what we want to do. Pay attention. It's going to be 2 distributive properties. 2 separate problems. So remember, the first one, we take the x, we multiply it all the way through. So we have x cubed plus 3x squared minus 4x. Okay, then put a plus in between, put a parentheses. So you know, so your brain knows, now we're going to do the negative 7. Now we're going to take the negative 7 to all 3 terms. Okay, so negative 7 times x squared is going to be negative 7x squared. Negative 7 times 3x is going to be negative 21x. And negative 7 times negative 4 is going to be positive 28. Okay, now all we got to do is combine like terms and we're done. So is it really that hard? No. Could you make a silly mistake? Yeah, but that's why we got to practice. That's why I'm giving you homework. Okay, so let's combine like terms here. So is there another x cubed? There's not, right? So bring it down. 3x squared minus 7x squared is going to give me negative 4x squared. Okay, negative 4x minus 21x is going to be negative 25x. And we have plus 28. And yes, I still cross these off like I'm in 3rd grade. Deal with it. Does this make sense? Okay, we have a cubic. What tells me this makes sense? How many zeros did we start with? We started with 3. We ended up with a cubic. That makes sense, right? Okay, a lot of you guys are like, no, it doesn't. Well, We'll work on it, okay? Your brain's got to get warmed up. You're not supposed to get this right out the rip. Playing Call of Duty for a month straight. 3 weeks, whatever, how long we were off. Okay? Let's move on to the next one. This radical, don't let it freak you out. It's not terrible. Okay? How many zeros do we have here? We have 2. Okay? Turn these back into their binomial forms. Remember, it is opposite. Why is it opposite? Because I have to set both these equal to 0 and solve for x, and then I get the zeros. Alright, now all we got to do is FOIL, first, outer, inner, last. Do not let this confuse you. Radicals are not scary. Okay, watch. I'll prove it to you. First is going to give me x squared. Outer is going to give me plus root 5x. Just stick it on the end like to any other number. Minus 10x. Okay. Now, we have negative 10 times root 5. Are you going to put the negative 10 inside the square root? I will slap this camera. Don't do it. Okay? Here's what we do. Stick the 10 on the outside of the square root and call it a day. Okay? Don't try to turn this into a decimal and combine like terms here. Don't do it. Just leave it. I know what you mean. Okay? I'm not going to put any hard ones that aren't custom on Delta Math like this. I know you can do it. I want the process. You guys get the process down. Alright, let's do one of the harder ones. Which one should we do? I'll leave 8 for you guys because it looks fun. Have at it. Okay? Have at it. Let me know if you got questions on it. You probably will. It's a challenging one. Okay, let's start with number 7. Okay, here's what we want to do. So I want to turn these into, I'm going to have a binomial for the 8. Okay, and what I'm going to end up with, pay attention here. I'm going to end up with a trinomial, okay, 3 terms for both my 3 minus I and my 3 plus I. Okay? Alright, here's what's going to go down. So, I know I'm going to get x minus 3. Why do I know I'm going to get x minus 3? Is because I know both these have a positive 3 in it. So I know x minus 3 is going to be in there. But I have to do the opposite of the i's. So on my first one, it's 3 minus I. So this is going to be x minus 3 plus I. Okay? My last one's going to be x minus 3 minus I. Because it's opposite. Okay? If I set both of these equal to 0 and solve for x, I would get this and I would get this. Alright, that is how you do those. Don't get confused by it. Alright, now it's going to get tricky. Ready? Alright, here's how we do these. Okay, we are going to knock out the trinomial times trinomial first. Okay, so forget about the x minus 8 for right now. We'll worry about that at the end. Okay, what I want to worry about is this. And you guys will get lost if you don't stay organized here. Okay, so we're going to do each term one by one. Okay, you can either do the left into the right, or you can do the right into the left. It doesn't matter. I'm going to do left into right, because that's how we read. So I'm going to go this way. Okay, so watch. Should I use fancy colors? Yeah, I think I can. Alright, let's do it. I don't want to confuse you guys here. I'm going to take x to all 3 terms, I'm going to take the negative 3 to all 3 terms, and I'm going to take the I to all 3 terms. It's going to be 3 separate distributive properties. Distributions. Okay, so the first one, I'm going to take the x to all 3 terms. So we have x times x, which is going to be x squared. X times negative 3, which is going to be negative 3x. We have x times negative I, which is going to be negative ix. Okay? Second one, I'll switch colors to green. Take the negative 3 to all three terms. So we have negative 3 times x, which is negative 3x. We have negative 3 times negative 3, which would be positive 9. Okay, and then we have negative 3 times negative I, which will be positive 3I. Okay, last but not least, I'll switch to red now. Just forget about this one for now. We're going to run into the space here. Takes up a lot of space. I should have wrote smaller. So we have I times x, we have I times negative 3, we have I times negative I. We're going to get something cool here. So we have I times x, which is positive ix. We have I times negative 3, which is we have negative 3I. And we have I times negative I, which we have negative I squared. Okay, does anybody remember what I squared equals? Review. What does I squared equal? Huh? It equals negative 1. Okay? So, let's combine like terms with that in mind. We can go ahead and change this. So if I squared equals negative 1, and I already have a negative out front, it's just going to be plus 1. Okay, let's go ahead and combine like terms. Make this look a little prettier. Okay, do I have another x squared? I don't. So bring it down. Cross it off like a third grader. I don't care. I got no shame. Okay, second thing we need to look for is the x's. We have negative 3x minus 3x. It's going to give us negative 6x. Okay, do we have another one? No, we don't, right? It's going to give us negative 6x. What about the ix's? We have negative ix plus a positive ix, which they're going to cancel out. I don't need to write anything. We have a 3i and a 3i. We have a positive 3i and a negative 3i. They're going to cancel out. I don't need to write anything. Last but not least, we have positive 9 plus 1, which would be positive 10. Alright? We're almost done. Okay, remember. Now we don't want to forget about it. That last one probably seems like chump change compared to this one. Huh? Remember, math builds on itself. So if you don't understand something, you got to get that figured out, because it's just going to keep building and building and snowballing. And that's when everybody gets stressed out. Okay, don't let that happen. Let me know. I can help. Okay, we have a binomial times a trinomial. It's the same process. We take the x to all three terms, and then we're going to take the negative 8 to all three terms, and then combine like terms. Okay, I'm going to do the x first. We have x times x squared will give me x cubed. X times negative 6x will give me negative 6x squared. And then we have positive 10x. Okay? Then negative 8, we have negative 8 times x squared will be negative 8x squared. We have negative 8 times negative 6x will be positive 48x minus 80. Negative 8 times 10. Combine like terms here. Third grader time. We don't have another x cubed. What about the x squareds? We have negative 6x squared minus 8x squared. Okay, we have negative 14x squared. Cross them off like a third grader. 10x plus 48x gave me 58x minus 80. Whew. It's a lot, I know. I ain't going to give you a bunch of those on the test. I promise. Maybe one. Okay? Gotta know how to do it. It's a lot of work. Write small, stay organized, go step by step by step. Use different colors if you have to. Okay, does this make sense? How many solutions do we have? Well, we have 1, which is the 8. One complex number, the 3 minus I, and we have another one, 3 plus I, sorry, excuse me. The negative half first, and then we have the positive half. Do not forget to write that in. It's kind of like a trick question. I'm going to give you a negative I, but you have to know that you have to have the positive half. Alright, that's it. That's the whole video. Okay? Remember, it gets signed in Delta Math tomorrow. If you're watching this, then you are on Delta Math. Okay, congrats. If you don't know how to get into Delta Math, use that resource I showed you earlier, or email me. We will hop on Zoom and we'll figure it out. Teamwork makes the dream work. All right, what's the time at? 50 minutes on the dot. Ooh, it's like I've done this before, huh? All right, see you guys.